Hello viewers, welcome to the eMath learning platform for the continuation of proportions. We are specifically going to handle what we call partial variations. Now in our introduction, we are going to begin by the most important statements that are always used in problems that involve partial variations. And now, for example, let's look at a situation where two variables y and x are joined by a general equation, but where k1 and k2 are constants. Let's look at a few examples of this. Part A, y equals to k1 plus k2x. What do we say in case we have an equation of this kind? Now, we simply say that y is partly constant and partly varies as x. Now, when you look at this, k1 is a constant, but we also have another variable here, though connected to another constant. So in this case, as long as we have y equals to k1 plus k2x, then it means y is partly constant, but partly varies as x. And this k2 is going to be the constant of proportionality for the variation between y and x. K1 is very clear, it's also a constant because they said y is partly constant, but also partly varies as x. So these are the statements you'll always meet in the questions, and you will be able to come up with the equations that are supposed to be respecting the statement given to you. Another form could be of this kind. Y equals to k1 plus k2x squared. Now, what is the difference between this and this? The only difference between this and this is that here we have x squared, but here we had x. So what does it mean? This equation tells you that y varies partly as a constant again, but it also varies as the square of x. That is the difference between the two. Another form that they can give you could be of this kind. Y is equals to k1 plus k2 out of x. Now, how do we say this out mathematically? This means that y varies partly as a constant again, but inversely as x. That is what you have to note clearly. Here it was directly as x, but here it is inversely as x. So we simply say that y is partly constant and partly varies inversely as x. Now, in most of the questions we shall be handling, they will give you most of these statements, and you will be required to come up with the expression of any form. We could have any other. For example, someone could be having y is equals to k1 plus k2 out of x squared. So that will mean that y varies partly as k1 and and inversely as the square of x. We may not be able to have all those examples here, but we shall elaborate more in the examples as we shall look at. Let's go and begin with the first example for this tutorial. Question 1. The cost in shillings of a roll of a cloth is partly constant and partly varies as the square of the length, L in meters, of the cloth. The cost of a roll of 50 meters is shillings 50,000, and the cost of a roll of 80 meters is shillings 96,800. What does the question say? Now, part A of the question will tell us that we should form an equation relating the cost C and the length L. Part B, calculate the cost of the roll of length 20 meters. And part B, Roman 2, we should calculate the length of a roll which costs shillings 34,700. I beg your pardon on that. Let's look at the solution. Now, we are beginning with part A. But before we do it, let's first go back to the equation and look at how we can come up with an equation basing on the statement given to us. So the question says the cost C, so this is our variable C, of a roll of a cloth is partly constant. That is very important. And partly varies as the square of length L. Partly constant and partly varies as the square of the length L. So it means we shall simply say in our solution, we shall say that C is equals to K1 plus K2 L squared. So it is partly constant and partly varies as the square of L. Now, I am just deciding to use K1 and K2, but you could as well use any other constants of your choice. Now, after we having this equation, we simply begin substituting in the conditions we're given, and finally, we shall go and form two simultaneous equations that we shall solve by either elimination, substitution, matrix method, or any other method of your choice. But we shall prefer elimination or substitution for the sake of simplicity and time saving. Now, remember they gave us in the question, they told us that when L is equals to 50, C is equals to 50,000. That is when you get back to the question. So we simply substitute these values. Where there is L, I'm going to substitute for 50, and where there is C, I'm going to substitute for 50,000. And that gives us that next step. Then after that, you simply simplify this. This will tell us that now 50,000 is equals to K1 plus 2,500 K2. That is when you square 50, you get 250, 2,500 I mean. Then from this point, we shall simply call this very equation our equation 1. We go for the next condition. Remember, they should always give you two conditions because they are going to be two unknowns. So when L is equals to 80, C is 96,800. That is what we're given. So when you do the substitutions again in the very equation that we started with, it means you shall have 96,800 is equals to K1 plus K2 into 80 but squared because our L here is squared. Then after that, you simply do the simplification, and that will give you 96,800 is equals to K1 plus 6,400 K2. So we simply now rearrange that and again call it our equation 2. Now that you have equation 1 and equation 2, they both have K1 and K2. So it means we are going to be solving for K1 and K2. We shall solve them simultaneously. Now, which method are we going to use? I'm going to simply use elimination for the sake of simplicity. So I can say, since I see K1 and K1 in both equations, I can eliminate it by simply subtracting either equation 1 minus equation 2, or I can say equation 2 minus equation 1. So I will decide to take equation 2 minus equation 1. So it means when I get this equation minus this one here, K1 will cancel. And so we shall have 6,400 K2 minus 2,500 K2. When you do that, it will give you something related to what we're going to have in our next step here. It will give you 3,900 K2 is equals to 46,800. How have we got 46,800? By simply getting 96,800 minus 50,000. Then from that point, we shall simply divide through by 3,900 to get the value of K2. So now K2 is equals to 46,800 out of 3,900, and if you press this in your calculator, it will give you the value of K2 as 12. Now that we have the value of K2, we can now go back to any equation, either equation 1 or equation 2, and we look for the value of K1. Now I'm saying from equation 1, K1 plus 2,500 K2 is equals to 50,000. Now, if this is true, then I'm simply going to substitute for K2 as 12. When I do so, I will have K1 plus 2,500 into 12, giving us 50,000. And when you multiply 2,500 by 12, you get 30,000, which now gives us K1 plus 30,000 is equals to 50,000. Then we simply take the 30,000 to the right hand side, and so it means we shall have K1 as 50,000 minus 30,000. When you do that, you will come up with the value of K1 as 20,000. Now that we have the value of K1 and K2, you simply go back and substitute them in the original equation that we started with. And so that gives you the equation relating C and L as C equals to 20,000 plus 12L squared. At this point, you will have got almost 3/4 of the total marks that are given in that problem. We can now proceed to part B and look at Roman 1 of it. Roman 1 wanted us to find the value of C, that is the cost, when the length is 20 meters. So when you simply go back to our equation that we have come up with, you simply substitute for the length as 20. And when you do so, you will come up with 20,000 plus 12 into 400, because we squared 20 to give us 400. And from that point, by simplification, you'll get the cost, which is C, as 24,800. So we can make a conclusion that the cost of a roll of length 20 meters is shillings 24,800, and that perfectly answers Roman 1 of our part B. We can move on to Roman 2. Roman 2 now, this time they wanted the length when the cost is 34,000 when you get back to the question. So I simply substitute for the cost as 34,700 and I look for the value of L. Now from here, it's a matter of playing with the mathematics, and we go on to find the value of L. Now, when you look at that, we shall simply take the 20,000 to this side such that we have 34,700 minus 20,000, giving us 12L squared. Then the next step from there is, after subtracting this, we shall be having 14,700. But now we divide through by what? By 12 on both sides. And when you divide that on both sides, you will get 1,225. But remember, this is the value of L squared. And to get the value of L, we simply take a square root on both sides. And when you take a square root on this side, remember the square cancels with the square root. And so we shall remain with the square root of 1,225, which finally gives us 35 meters as our value of L. What will be our conclusion? The length of the roll, which costs shillings 34,700, is 35 meters. So that perfectly answers Roman 2 of our part B. And finally, we are able to answer the entire question 1. Now let's proceed and look at question 2 and also see how to develop more and more. Now question 2 says the cost C of operating a day school for 1 day is partly constant. Now these are the important statements. Partly constant and partly varies as the number of students n. Very good. Now they're telling us that it costs shillings 40,000 to run the school when there are 500 students, and shillings 64,000 when there are 900 students. Part A, form an equation for the cost C and the number of students n. Part B, what would be the cost of running a school when there are 700 students? And final part C, if the cost of running the school is shillings 82,000 per day, how many students are in the school? Very comprehensive question. Now let's move on and look at the solutions. Now in the first case, they told us that the cost varies partly as a constant. So we are having our constant here, and partly as the number of students n. So we have the number of students n, and this K2 is its symbol or sign or constant or proportionality. Now that we have C is equals to K1 plus K2 n, we simply bring in the conditions. Remember, they told us that when n is equals to 500, C is equals to 40,000. N represents the number of students and C represents the cost of running the school in 1 day. So we simply substitute for n as 500 and C as 40,000. When you do so, we shall have 40,000 for C is equals to K1 plus K2 multiplied by 500. And that gives us our first equation, which will be K1 plus 500 K2 is equals to 40,000. Then the next conditions were also given as N as 900 when C is equals to 64,000. We again go back and substitute in the very original expression that we came up with. And when you do so, you will have 64,000 is equals to K1 plus K2 multiplied by 900. And that gives us K1 plus 900 K2 is equals to 64,000. And that is our equation 2. Now we simply solve these two equations again simultaneously. I am going to again say equation 2 minus equation 1 simply to eliminate K1. Now when I eliminate K1, I will come up with 400 K2, which is obtained by subtracting 900 K2, by subtracting 500 K2 from 900 K2. So when you get 900 minus 500, you'll get 400. But K2 giving us 24,000, which is obtained by subtracting 40,000 from 64,000. Then we simply divide through by 400. When you do so, the value of K2 will be 60. Now that we have the value of K2, we simply go to any of the equations, either equation 1 or equation 2, and we look for the value of K1. So now we are going to equation 1 again, that K1 plus 500. Now remember, this is our equation 1. Now this is K2, but we already know the value of K2 as 60, so I'm directly substituting it there. So it means you'll have K1 plus 500 multiplied by 60 is equals to 40,000. And that will take us to the next step, which will be K1 is equals to 40,000 minus 30,000, which we obtained by simply multiplying 500 by 60. So from that point, we can now be able to get K1 as 10,000. And now that we have the value of K1 and K2, simply write your equation that is required. So our required equation becomes C is equals to 10,000 plus 60N. That is the equation they wanted from part A. Let's move on to part B. Part B, they wanted us to find the cost of running the school when there are 700 students. That is why you see where there is N, we're now substituting for 700. You simply use the equation you've obtained, this one here. So I've substituted for 700, and by simply pressing your calculator, you will come up with 52,000. And our conclusion will be that the cost of running a school when there are 700 students is shillings 52,000. Let's look at part C. Part C, they wanted us to find out how many students would be catered for if the cost or the amount available was 82,000. So it means our value of C is 82,000, and so we substitute again in the very equation that we obtained. If this is 82,000, we shall have it as 10,000 plus 60N. Then here we take the 10,000 the other side, then finally we divide by 60 to get the value of N. So 60N is equals to 82,000 minus 10,000, which gives us 72,000. But if you divide by 60 on both sides, you will come up with 1,200. So from that point, we can now make a conclusion. So there are 1,200 students in the school, if at all the cost was the 82,000 shillings that they talked about. Now this brings us the end of this tutorial because it is kind of complex. So meet you again in the next tutorial where we shall add on more and more examples, especially under partial variations. Thank you for being good viewers.